everyone. Right now we're going to do the example briefing for Minneapolis, Minnesota. And this is valid a few days ago, but I wanted to go ahead and give you guys an example so that you would know what to do and not give anybody an unfair advantage of me already analyzing their charts. So for our first chart, you see that we're on 250 millibars. Right now, you see that we have broad anticyclonic flow upstream of Minneapolis, and with this anticyclonic flow, we have supergeostrophic flow, which is causing some arrows to point towards Minneapolis. Downstream, you see the subgeostrophic trough, and between these two vectors, we're going to have convergence at our station. However, with the speed term, we see that we have a very large arrow located just to the north of Minneapolis, and this is associated with us entering the jet streak. Right below Minneapolis, we see that we really don't have very much contouring. We have slight deceleration ahead with a bit of acceleration in front, so we are in the inflection point, so technically there wouldn't be any sort of advection of speed in this area. So right now we're under overall divergence via the term speed term, but since we are in the left entrance region of the jet, this overrides any convergence that we would see from our pattern. So right now we're under overall divergence. With our 500 millibar chart, you can see that we are under a broad ridge that is extending down from the Pacific coast of Canada into southern Nebraska. Associated with this ridge, we have a little bit of anticyclonic vorticity, especially out here in western Iowa. And right now, as this ridge passes over us, we're going to be moving into more of a positive vorticity advection area associated with this long wave trough that we see off the coast of Canada in the Pacific all the way down into Texas, and this trough is going to be the main weather maker for the rest of our forecast period. For 700 millibars, you can already see that some moisture is being advected into the mid-altitudes by this short wave long wave trough, and we see that this area of dry air would be underneath the 500 millibar ridging. So this is where our pocket of dry air is. Now that that is moving out of Minneapolis, we can expect our column to moisten throughout the next 12 hours. At 850 millibars, you see that we are becoming, that our station is slowly being entered into a warm air advection regime with a broad area of warm air advection extending from Texas all the way up right to our station in Minneapolis, St. Paul. Behind this is some cold air advection, and this cold air advection is only expected to strengthen as the low associated with that 500 millibar trough progresses across the country. And this is evident at the 12Z surface analysis by the WPC. You can see that they have an occluded low that is reforming at a brand new triple point. They have two triple points analyzed, but I do believe that the southernmost triple point is the one that is the real triple point, and you can see that is undergoing some frontogenesis with this warm front that is over western Kansas at this time. You see that we have a bit of a lead troughing feature, and behind that lead trough is the cold front that will be the main source of weather generation throughout the next 12 hours. As we progress, you can see that this warm front has coalesced into a real warm front with a pretty good dew point spread now becoming evident across it. So I do believe that this warm front placement is appropriate on the WPC's part. You can also see that this cold front is becoming co-located with this trough, and this cold front, or portion of the cold front up here, I believe that's the one that's going to make its way into Minneapolis, St. Paul, and possibly bring us some wetter weather. You can see that by 18Z that the cold front and warm front have surged forward, the warm front making its way towards Minneapolis, St. Paul much quicker than the cold front. And by 21Z, you can see that we are basically under a warm front, pre-warm front passage, and we should be able to find the warm frontal inversion on our sounding. By 0Z, you can see that I went ahead and pulled the SPC charts because these are the charts that are going to be available to you guys the morning of your briefing. And you can see that we are right under the ridge, if not just behind the ridge, that was making its way towards our station at 12Z. This would be an overall transport regime, unless you believe that this ridge has progressed a little bit farther than the SPC has analyzed, in which you would be under a divergent regime with this upcoming trough passage that is now located in Arizona and New Mexico. With this speed, you can see that we have very sharp acceleration out to the northeast of our station and nothing really on the southwest of our station. So this would also support the divergent pattern that is probably over Minneapolis at this time. By 500, you can see that this ridge now, as it had done in the 250, is also passing through Minneapolis, so we can look for some cyclonic vorticity advection now, and this is more evident over Montana. You can see that if we put a pinwheel through this barb that's 50 knots and this barb that is 15, that we are generating quite a bit of cyclonic vorticity advection, and this wind pattern would support that advection coming into the Minneapolis-St. Paul area. At 700 millibars, you can see that that moisture that we saw in the previous 12 hours has only strengthened. It has been fueled by the Gulf of Mexico and this troughing pattern bringing this warm air up from the Gulf, and this could help in the formation of some rain and some heavier rain later today. For 850 millibars, that diffuse warm air advection pattern that we had seen at 12Z is now much more coalesced by 0Z. You can see that we have some tightly packed isotherms, which is indicative of that warm front being right under this deformation zone. At theta E, I couldn't pull a map back that far, so I got 4Z on the 24th, which is as close as I could get. You can see that this feature on theta E is probably more located with your dry line and not with your cold front. Your cold front is probably hanging back here in this weaker gradient, because right now this cold front isn't as strong as it will be within the next 12 hours. But the warm front actually is much more defined on theta E than the cold front is, which is an unusual situation, which means that this warm front passage is almost definitely associated with some mesoscale level lift. And the 1,500 millibar thickness, I know this doesn't really look like the 1,500 millibar thickness maps that we looked at, but you are able to pull from anywhere you want. So you know that Twister Data has a 1,500 millibar thickness map with filled in colored isotherms. So if this helps you, then that's great. You can see that they had 2 lows stamped, and we saw that was evident on the 21Z surface map. I went ahead and connected these lows with a trough and not with an occlusion, because the thickness gradient doesn't really support any sort of frontal feature being through here. Your cold front is draping back below the borders of New Mexico and Arizona, with your lead troughing and probably your dry line being right through here, through the panhandle of Texas. Your warm front is, on the surface map, they had it analyzed a bit farther forward, and I agree with that. However, I couldn't justify putting the front, as far as this analysis, in that area because there was no cyclonic turning of the isobars. So I went ahead and put it down here. Whenever you guys do a briefing for Dr. Blackwell, your 1,500 millibar thickness charts can be different from your surface charts. Just make sure that you provide justification for doing so. For our soundings, you can see that this is a sounding for Minneapolis-St. Paul, and right here at about 800 millibars, you see a sharp frontal inversion supporting that cold front that HPC has analyzed back farther to our southwest. You also see a subsidence inversion right below that frontal inversion, which may be inhibiting a little bit of our rain right now. But as that frontal inversion comes through, and as the never mind. I'm sorry. I got confused with somebody else. For OAX, which is in eastern Nebraska, you also see that that frontal inversion is much sharper and much shallower, which means that the warm front is much closer to this region. So we know that at 0Z, the warm front has not made it all the way through Nebraska, so we can expect a warm front passage to happen between 0 and 12Z. For our 300 Kelvin isentropic map, you can see that we are under a broad area of strong isentropic lift. You can see on this map it goes from 900 all the way up to at least 650, so that's through a good portion of the lower atmosphere, which would support some lifting mechanisms for clouds and possibly for rain, with all of this moisture being advected into the region. And I went ahead and pulled the 310, and this shows about when the isentropic lift stops. The wind barbs become mainly parallel to the isobar at 600, so you can expect that mixed layer to be capped probably right around 600. For our favorite chart in the world, the cross-section, I chose the cross-section from Rapid City to White Lake, which is from South Dakota to Michigan. So this is going right across our station from the west to the east. And you can see that right in here near the South Dakota station, this is where our convective instability is at its maximum. This is probably where our front is, and out ahead of this is probably where our cold front is. And out ahead of this cold front, you can see the moisture pooling that is evident of our warm sector, and right here is probably where our warm front is, where the d theta e dz is less than 0, right in this area. You see that we have high mixing ratios being advected very deep into the atmosphere, up to about 500 millibars, more closer to Michigan. And you could see that that was true on our isentropic map, how the moisture advection went much farther north to our east than it was right at our station. For my 500 millibar forecast, I forecasted the wind speed to rapidly increase as this this ridge passage comes over us. Right after the ridge passage, you can expect that supergeostrophic flow and the overall divergence from the trough to ridge relationship greatly strengthen our wind speed, and I expect the winds to turn to the southwest after that passage, but I don't really expect the temperature to change too much because we've already been under that warm air advection regime, and it basically hasn't changed over the past 24 hours, and I don't expect it to do much more in the next 12, especially with that overcast skies. It'll probably inhibit that warming of temperature since our clouds are high. For our surface station, at 12Z, we had 5/4, and because it's already overcast at 12Z, I don't expect there to be much more heating to raise this temperature very much. And because I can't raise the temperature too much due to the overcast skies, I can't raise the dew point. It's already nearly saturated, so I don't think that it's going to move between our 0 to 2 bubble. However, I do expect our pressure to drop because we do have that approaching front, which only occurs in troughing of the pressure pattern. Our winds are now going to be from the southeast because that front still hasn't approached us yet, and I expect it to basically be knocking on our door at 0Z. And 15-knot winds ahead of this front, and overcast skies due to the overall divergence at 250, some positive vorticity advection at 500. We were already moist at 700, and you can see that we were under vast warm air advection, so these are 4 really good ingredients that would give us some overcast skies. I also believe that there's a good chance that there could be rain at this station at this time. And does anybody have any questions?